Hello, I'm here to. So it was very nice to talk to you all earlier this week. As promised, I've recorded this video to try and give you an overview of the model that I have developed to estimate the emissions from beehive stove use in different districts of Hanoi and the costs of cooking using beehive stoves versus the costs of different alternatives. So the model has been developed in Excel, and it would be great to get your feedback on thoughts on what can make this better, and how the results can most effectively be presented. So alongside this Excel spreadsheet, I also have attached a methodology document that describes how the emissions have been calculated, how the costs have been calculated, and then some key questions. So I just wanted to take you through how the model has been set up, where the different data are stored, and how you can navigate through it. And it'd be very useful to have some calls and some discussion about how we can improve this. So the aim of the model is to estimate the emissions from cooking using beehive stoves, and I've done this, the model is set up to calculate those emissions monthly for historical emissions from 2017 to 2019, which is data that Hanoi EPA provided to me, but then also for different projections into the future up until 2021, which is when I understand that the law on not using beehive stoves, it has to be fully implemented. So I also understand the alternatives that people are switching to are gas stoves and electric stoves. So in the model here, we have key information about beehive stoves, how much fuel is being consumed, the energy content of that fuel, and then the energy consumption is calculated from those values. The price of a stove, the average lifetime of a stove, and the price of fuel. And then there are emission factors here for 12 different pollutants taken from international data sources. So it would be fantastic to review these inputs for beehive stoves, then for gas stoves as an alternative, and for electricity as another alternative, to make sure that the values are the best that are available to represent the situation in Hanoi. The input data is then, so we have the cooking data here, and then we have the number of households that there are in each district cooking using beehive stoves. So we have the data here for Ba Dinh district, for example, for 2017 to 2019. This is historical data in the colored cells. And then there is data for 2020 and 2021 in the white cells that can be changed to represent different scenarios. So here we have a baseline scenario for each district, and I've just kept the number of households constant over time here, but we could change that. And then we have a mitigation scenario as well, where the number of stoves gradually goes to 0. And initially I've just made a linear interpolation between the value in December 2019 and the value in January 2021, where it has to go to 0. And I've then increased the number of people using gas stoves to replace those beehive stoves. So there's a switch between beehive stoves and an increase in gas stoves in this mitigation scenario. But we can change these scenarios to reflect different future projections of how the number of beehive stoves is going to decrease. So this is the number of households cooking with beehive stoves. In the next tab, we then have the fuel that is consumed. So that is the number of households multiplied by the average household fuel consumption. That is then converted into a consumption of energy in terajoules, and it's that energy consumption that is then multiplied by emission factors to estimate the emissions of different pollutants. We have that for those 12 pollutants. There is then a cost associated with buying the stove, and that is annualized over the lifetime of the stove. So it's the annualized cost of buying the stove, and then there is the fuel cost associated with the household consumption of coal for Beehive stoves or gas for gas stoves, etc. In the results tab here, we then have a summary for the whole of Hanoi. So this is not split by district. This is a summary for all of Hanoi in terms of the number of stoves in the baseline and in the mitigation scenario. So you can see here how they differ, the number of LPG and electric stoves, and then the emissions of the different pollutants in the baseline and the mitigation scenario, and the cost in the baseline and mitigation scenario. So the stove cost, the fuel cost, and the total cost for Beehive stoves for LPG, and then for the total cost here at the end. So I've included some graphs that show the difference in the costs, show the difference in the number of households and in the emissions. It would be very useful to understand whether these results look reasonable or whether any of the inputs could be improved. So I hope that gives you a quick idea of how the model has been set up. I'd be very happy to talk with you about how it can be improved, how the outputs can be visualized better, or how they can be made more meaningful. So hopefully we can have those discussions on Skype and also in person when I'm in Hanoi. Thank you very much.